In this one, we're going to look a little bit more about how to use cameras and some good techniques and bad techniques for moving them. So what we've got right now, if I run this thing, let's see what's going to happen. I can move my character back and forth, and the camera is not following my little character at all. So I built this level, just threw in some random glitch assets so that I could get from the start to the end. And I did write this little script, this little guy controller script, which is very simple. We've done this a million times in the past, so you can look through those tutorials specifically if you want to see why we do some of these things, or if this is a good idea or a bad idea. It moves, that's all I care about for this one. Get our key. If we have the right arrow, we're going to move to the right. If we have the left arrow, we're going to move to the left. We're just going to increment our X position or decrement our X position based on which key we're pressing down. I also started this camera move script that I attached to our main camera. So I right-clicked and said create C# script, and I named it camera move. Remember, there's no spaces. And then on my main camera, I just dragged it over, and that gave us our camera move script. So let's look at that camera move script and see what it does. So right now, it's pretty much empty. There is absolutely nothing in it except for a public transform target. This is who do we need to follow. And in this case, we want to follow our little guy. So this is the character that's going to be moving right and left, and we want the camera to follow that thing around. And right now it doesn't do that. So we're going to do a really quick follow script to start out with. And so what we want to do is just update the position of our transform. And remember, this script is attached to our camera, so when we say transform little t, we are referring to the transform that's associated with the camera, which is the location of it when we access the position variable, which we're going to do right here. So transform dot position, oops, equals new. And then for this one, trying to keep it as simple as possible with as few variables, we're only going to move left and right. So I'm not going to worry about X, Y, and Z. Or I'm sorry, I'm not going to worry about Y and Z. We're only going to worry about translating things in the X direction, horizontally. Equals new vector 3, because for the camera we need to keep track of 3 dimensions. And it's going to be target dot position dot x. So this is the x value of the character. And then the y and z values we're going to leave the same as our current position. So we'll say transform dot position dot y and transform dot position dot z. And so every time we come into this update loop, we are going to reset our position to match that of our target, and we'll leave our y and z values alone. Too many parentheses. And so if we run, we'll notice that the camera does follow our guy as we go. It's a little bit jerky though when we turn directions. In a lot of games, what will happen is there'll be sort of a dead zone in the middle where the character is free to walk back and forth. And then the other thing that we can do is we can get a little bit of acceleration so the camera just doesn't snap. Now, it doesn't mean that this is bad, like that this is a bad way to move the camera around. It just means that based on your game, you may want to try and do something else, just based on the way you want to do things. And so we're going to look at a couple of different ways to do that. The first thing that we're going to do is to put in a little bit of an acceleration and deceleration with the camera whenever we move. It'll give it a little bit of a different look. So right now, just remember so you can look at the differences. This is pretty much as soon as I'm hitting the key, we're moving back and forth. We're going to add it so that there is some time for the camera to accelerate and some time for it to decelerate. And so we're going to do that back in our script. And we need a couple of variables in order to do that. One of them is going to be the damp time. So this is going to be the acceleration and decel. How quickly do we want to catch up to where our player is? So we're going to make that a public variable, but we'll switch it in a sec. We'll make it public so that it can be switched inside of Unity if you don't like the speed. So public float damp time. We'll start with 0.1. About 1.5. And then the other thing that we need to keep track of is how fast we're going, and we'll use that in a sec. So I'm going to make another a private variable. It's going to be a vector3. It's going to be velocity. And for now, we'll zero it out. Vector3.0. So that's going to start our velocity out at 0. So then, when we come into our update loop, I'm just going to comment this one out because this one works fine. It may not be exactly what we want, but I'll just comment it out. And so inside of our update loop, basically what we need to do in here is calculate, how far away are we from the target, and then we need to move into that direction. So the first thing that we need to do is figure out where the character is in the viewport of the camera. So we have several different coordinate systems going on. We've got our world space, which is, coordinates in this entire thing. And then we also have a coordinate system based inside of what our camera can see. And this goes from 0 to 1 to 0 to 1. And so 0.5 is right here in the center. And that's a different coordinate system. So you can always tell where your objects are in relation to what the camera is looking at, in addition to where it is in the entire world. And there are some helper functions that we're going to use that'll help convert our coordinate system from one to the next. And that's what we're going to do here. So we'll say vector3 point equals camera dot main world to viewport point target dot position. All right, so we're taking the world point of our target dot position. This is the character we're trying to follow, and we're converting it to the viewport point. So where is it in what our camera sees? And now we need to know, where are we moving to? So how far do we have to move? Vector 3 delta equals target dot position minus camera dot main dot viewport to world view viewport to world point. And what are we going to pass into that? New vector3 of 0.5, 0.5 point dot z. Okay, so what is all of this stuff? What does all this thing mean? Well, basically we calculated into our viewport where our target is, and then we're doing the delta, and what we're trying to figure out is how far from the center of our camera is the target. And that's what this 0.5 business is. That's the actual middle of what our camera is seeing. And so we want to know where our target is, how far is that from the actual center of what our camera is looking at. That's what this whole thing is. That's what our delta means. All right, and then based on that, we're going to move. So vector3 destination equals transform dot position plus delta. That's it. So we're going to take our current position of the camera and then move it by this delta, which is what we calculated here. So this part right here is pretty much just getting the z value, because we don't want to move that around. We don't want to move the z value of the camera around. That's going to be really strange. Only thing we want to do is move it either horizontally or vertically to follow our character. And so we need to get the z value so we don't mess with it. And then we do this delta here so that this will essentially be 0. And that we're only looking at the difference between the center. All right, and once we have that, we still haven't done anything yet because we need to update our transform's position. So we'll say transform dot position equals vector3, and this is where we do some cool stuff. Vector3 dot smooth damp, and we'll say transform dot position to our destination. Oops. So this is where we're at. This transform dot position where we're going is our destination. And we'll pass it the velocity as a reference. Remember, at the beginning it's going to be 0. And then this is our damp time. So here's the parameters that we go there. Where we're at, our target, how fast are we going, and this is our smooth time. How smooth do we want this thing to be? And you can mess around with different values of damp time and see what the difference is. But that's it. And so now if we go back and we run, we'll notice the camera is slightly different. So see how there's an acceleration and a deceleration? So when I let go now, the camera kind of slides into place. So that gives it a really cool feel. And if we click on main camera, over here is our damp time. I can start to pick that up a little bit and see what the difference is. And so now at a 1, it takes it a lot longer, like a full second, to snap into place when we stop moving. So depending on what you're trying to do and the look you're trying to go for, maybe that's good and maybe it's not good. But that's what it is. So I'm going to leave it at 0.15 because that seemed to work pretty good. So the other thing that we can do with cameras, and like I said, it doesn't matter what camera style you use as long as it's right for your game and it's what you want. So we're going to add one more thing to this, which is we want to make sure that if the player is sort of just moving around in the center area, that the camera is not going to move. And some games do that. So there's sort of like a dead zone where you can move left and right. And that's the part of the code that we're going to put in right now. I think we'll still use this part of it, but we'll double check to make sure that the player is not in that dead zone before we go ahead and do this. So one of the things that I'm going to put in here is we need a Boolean to check and see if the camera is moving, because if the camera is moving, then we're good. If it's not, or if it is moving, if it's not moving but switching to moving, we got to check and see how far away we are from the center to make sure that we don't start moving the camera too soon, because we have this little window where we don't want to move it. So we'll say bool moving equals false. And inside of here, we're going to put a check before we do this. We'll say if we're moving, or, so if we're moving, we're still going to keep moving. And we'll set what moving means in a second. But if we're moving, or the distance, vector2.distance, between our current position and the target is greater than some threshold. And we'll put that in a second. So if we're moving or we're beyond some threshold, then we will allow the camera to move according to this algorithm that we have here. And I'm also going to set moving equals to true just inside of this thing. Okay, so this threshold, this is going to be the distance that we want to have the dead zone in. And essentially, it's going to go on either side of the player. We're going to have this threshold amount of distance. So I will just make a public variable, because I don't really know what it's supposed to be, but I'll say public float threshold equals 1. And we can change this inside of Unity if we want to, but this is going to be a good starting point. So if we're moving, which we start out we're not moving, or the distance is greater than this threshold, then we start updating this thing. Now, we never set moving to false. And so how are we going to do that? Well, we'll kind of cheat. We'll just say something like if we release a key, we'll just say that we've stopped moving. So if input.get key up of key code dot right arrow, or input.get key up of input or key code dot left arrow, then we can say moving equals false. Because right now we know that we're only moving by using the right arrow and the left arrow. There's probably better ways to do this, like we need to double check with our player controller or guide controller, whatever we called it, to see if that thing is actually moving. But for now, we'll be able to do it this way, and it'll work out okay. So I think that's all we need to do, and I think we'll end up with our little dead zone. So there it is. So you can see that it is taking its time to slide into these different places. I can increase that dead zone a little bit, but right here, see, we're not even moving. The camera isn't moving because our player is going back and forth in the center here. And then once I hit those boundaries, it'll start to follow it. And we can increase this threshold by, a little bit. About that. And now we can go further without the camera moving. And so, yeah, you can just start adjusting these parameters. But that'll give you a little bit about, and maybe we need to make this damp time even bigger now. Something like that. There. So there, now we're moving back and forth. The camera's not moving. Then we start going. We slowly stop. And then we're going back and forth without the camera moving. Go forward. Slowly stop. Back and forth. No camera motion. And so, yeah, that's a different way of dealing with the camera. I think we just went through probably 3 different ways to handle the camera in a side scroller that are fairly similar, but they all make the game have a slightly different behavior. So I think that's it for different ways to move the camera.